Okay, so let's try to talk about let's call it the construction, how the cochlea is built. So let's start with where the sound wave comes from, or more precisely, how the vibrations goes in the ear until they get to the cochlea. So we are talking about the external ear canal, where the sound wave goes in as air waves. Then the tympanic membrane vibrates, which vibrate the ossicular chain, which consists of three bones. We start with the malleus goes to the incus and then stapes. The stapes is connected to the oval window on the cochlea, one of the opening between the inner ear, cochlea, and the middle ear. And when the stapes vibrates, it causes vibration of the fluids, the lymph in the inner ear, the perilymph and then the endolymph. And now the cochlea, if you look, it looks like a cochlea. So it has the base. The base is the start of the cochlea, where the oval window move, if you want to call it that way. This is where the high frequency sound is translated throughout the hair cells. We have the inner hair cells and the outer hair cells. And the apex, if you're going throughout the cochlea until the end, this is the apex. There, the low frequency sound waves are translated to electrical signal throughout the hair cells and from there to the cochlear nerve, which is part of the eighth cranial nerve, the vestibulocochlear nerve. Now, in the base and in the apex and all around the cochlea, the sound wave is translated from waves, fluid waves of the endolymph and perilymph, to electrical waves throughout the hair cells. There are inner hair cells and outer hair cells. Now, the outer hair cells, their main role is to amplify the signal and make it more precise. So they not the one that translates the sound from mechanical wave to electrical wave to the cochlear nerve. This function is the function of the inner hair cells. The inner hair cells are the one that actually takes the wave, the mechanical waves, and translate them into electrical signals to the cochlear nerve, which is part of the eighth cranial nerve. The outer hair cells, let's summarize it. Outer hair cells are important for amplifying and tuning and fine-tuning the signal, the mechanical signal, to the inner hair cells, which the inner hair cells are the ones who translate the mechanical wave into electrical wave to the cochlear nerve and then to the brain. And one sec.